the video.
You,
All right.
I think you look good today.
Thanks. All right. So today we're going to study the square root function. All right. So when we think about a square root, let's think about what kinds of things can we take the square root of?
4.
Like what's the square root of 0? 0. What's the square? Oh, okay. So 0, 0. That'll be my first point. What about 1? Can we take the square root of 1?
No.
Yes.
It's 1. 1, 1. Got a point? And I heard David say this a second ago. 4.
2.
2. Okay. 4, 2. I like it. I like it. What's the next number? What's the next number?
16. No.
1 in between.
9
9.
is definitely in the square.
Oh, and then 16.
Oh, it's the little slant thing.
Yes. Okay, so our next one that we would do is 16. So when we're doing a square root, these are our moves. These are our moves from the translation point.
Will we give me permission to work ahead?
No. Because I'm going to talk about some important stuff. I don't want you missing. Okay. So I call this the eyebrow function. Looks a little bit like an eyebrow. It's got a nice little curve to it. Maybe it needs to be waxed. I don't know, but it's the eyebrow. Does the square root function have any symmetry?
No.
No, there's no symmetry here. None. There's no symmetry. All right. So what would happen if we took this parent graph, f of x equals the square root of x, and just added 2 to the end, guys?
Move it up.
It would just move it up 2. Up 2.
Wait, what?
A 2 added to the end of a function shifts the whole function up 2. So that point goes up 2, that point goes up 2, this point goes up 2, the whole thing. So from my translated point, from my translation point, I would go 1, 1, 4, 2, 9, 3. Do you see that those moves from that point are the, I wish I could hit my dots, are the same as if I had just taken each one of those and shifted it up 2? Let me try to do a better job of that. I missed exactly the same way again. All right. Now, what would this one do? Down 3. Okay, so if I started right here and did the moves, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Is it the same as shifting each one of those points down 3? Yes. You can say up and down.
Thank you.
Alright, so where did this one move the translation point? Up to 0, 2. Where did this one?
0,
0, negative 3. So in general, if we add something to the end, that shifts our y up or down.
Okay.
Alright, next one. This. Now, before we start this, we need to talk about what that radical does. That radical acts as a grouping symbol. And it groups everything that's under, just like parentheses were around it. A radical acts just like a grouping symbol. And for that reason, you're right. This minus 3 here is actually going to shift every point right 3.
So it'd just be, whoa, enter it into your calculator. Be up 3 over 1. You don't need no calculator. We don't have a calculator. What is that? Yeah. I can't follow the directions.
Well, yeah, we're not following the directions. So it's going to shift it to 3, 0.
Even in bold. True.
numbers. Why is it a problem right now?
I like the color.
Okay, so now this one. What could we do to the original function so that it would reflect over the x-axis? This would have a negative go out in front. So let's go back over here and graph that. I'll do that in black. Okay, so if we did a negative out in front, it's going to change all those to negative. So from this translation point, instead of going 1 up 1, we'd go 1 and down 1. Instead of right 4 and up 2, we'd go right 4 and down 2. Instead of over 9 and up 3, we would go down 3. So this is the function y equals the opposite of the square root of x. That is a reflection over the x-axis. Now, we haven't really done many functions where we reflected them over the y. But this one will actually look different. So we're going to approach that now. Okay? So this one will look different when we reflect it over the y. And that's what this asks. What could we change to reflect it over the y? And to reflect it over the y, it's the square root of negative x. So the negative is grouped under the radical with the x. So let's graph that one now. Instead of going right, we go left and up 1. Left 4, up 2. Left 9.
So it's got to be inside.
So if the negative is inside, it reflects it over the y-axis so that it opens this way. So this is the square root of negative x, which opens the door for something kind of cool. What if we negated both of them? What if we graphed y equals the opposite of the square root of negative x? It reflects it both ways, and it flips it down here in that third quadrant. And so that one looks like this. Okay. Now, 12 and 13 are taking us back up to number 9. So number 9 was just shifted right 3 units. How do we make it go up to this point?
Add 7.5.
Yep, that's all we do. Add 7.5. How do we shift it down to that point?
Add -3.
Yep, -3 to the end. Okay, just like the other day, all of that's a little too much. But when we have this graph, our translation point always goes to HK. When we're looking at our parent functions, our translation point goes to HK. Alright, so let's look at the back. Do you see that each one of these just has an A? Okay? So what does A do to a function? Does it move it? Does it translate? No. So what do the graphs all have in common? The translation point is the origin, because that doesn't move. That doesn't move. But what does change is vertical stretches or compressions. And Now also there's some negatives. What are the negatives called? Reflections. So how are they different? Some are vertical stretches. Some are vertical compressions. And some have reflections. Yes, ma'am.
Call it a shrink instead of compression.
You sure can. Alright, so let's talk about the characteristics by graphing it. Now, where does the translation point? Where does this move to? Okay, so I'm going to call that the translation point. It's the end point of the graph. And it moves to -2, -3. -2, -3. This is where my moves will start from. Now let's think about, we don't have to memorize because we can look at the function. It's got a square root. I have to pick numbers I can take the square root of. Square root of 1, 1. Square root of 4, 2. Square root of 9, 3. I don't have to memorize because I understand. Numbers I can take the square root of. Okay? Now, these are the normal moves from the endpoint, the translated point here. But this one has a 3. What does that 3 do to these moves? It multiplies the y's by 3. It is a vertical stretch by a factor of 3. Everybody that answered was right.
Vertical stretch. So that's y.
So,
You're putting on the
that
y.
affects the y's. Yes, vertical is your y's. So the moves from this translated point, right 1, up 3. Right 4, instead of 2, we're going up 6. 9, instead of 3, we'd go up 9. And it's a stretched out eyebrow.
Wait, how many did you go to the right? You went to the
Um,
right 9?
Yeah, I did 1, 4, and 9.
Okay. Davis.
Okay, so now let's look at the graph. Domain represents all the possible x values. Well, we don't get to use them all this time. It is not from negative infinity to positive infinity. What do you think it is?
Bracket -2.
With the bracket.
Very good. A bracket, -2 to positive infinity. These are all the possible x values I can use. Because if I plug -3 in here, if I plug -3, which is not a possible x value, do you see I get 3 times the square root of -1, which is imaginary, which doesn't plot on my graph, does it? I cannot use a value of -3. It won't work. All right, range. Range represents all our possible y values. And whenever we write an interval, we write it from least to greatest. So what is our lowest possible y value?
-3.
-3 to
Infinity.
infinity.
Bracket. Or parentheses.
Now, this translation point, is it a max or a min?
Min.
This is a min. So our min is at the point -2, -3. Now with radical functions, with square root functions, not all radical functions, but with square root functions, they're either going to be increasing or decreasing.
It's increased.
And this one's increasing. So it increases from, and we could use a bracket or a parenthesis here, -2 to infinity. And it doesn't decrease at all.
So it doesn't matter if it's bracket or parentheses.
It doesn't, actually. I have that single x-intercept at -1, 0. Now, it doesn't look like it crosses very pretty for my y.
Oh.
But how can I find my y-intercept if it's not pretty? I
Plug
can
it in.
always
Plug her up.
plug in 0 for x. Alright, so when I plug in 0, that goes away. And I get 3 roots of 2 minus 3. That's my y-intercept. So it would be 0. You could write 3 roots of 2 minus 3, or you could put it, usually when we write a number that's part rational and irrational, the rational part always comes first. I would not mark it wrong, though, if you wrote 3 roots of 3 roots of 2 minus 3. Now, end behavior is interesting too, because looking at this graph, does x approach negative infinity?
No.
No. So this is not even applicable.
And not applicable. Oh, I thought that meant not available for my whole life.
Cool. You learned something new today.
Not applicable.
Yes. It doesn't apply.
Not applicable.
That's right.
Why is it not? Why didn't it approach -2?
Okay. Sammy, the concept you're talking about takes us towards limits, which is an accelerated pre-calculus topic. I'm just going to tell you quick, and then we're going to go back to NA. If we had written that it approaches -2 from the right-hand side because it doesn't approach -2 from the left-hand side, then we could say that the function approaches -3.
Why so?
But that is an accelerated pre-calculus topic right before you get to calculus,
Great.
and you guys are not there. So we're going to say, hey, it doesn't approach negative infinity.
Let's go there.
Okay, I can't even get you to do your homework. I am not going to introduce limits.
No limits.
Alright, so as x approaches positive infinity, it does. This function does approach positive infinity. So y also approaches positive infinity. Okay, where is the function positive? It is positive from -1 to infinity. And this is interesting. Where is it negative? It is negative from -2 to -1. Now, I included -2. And I didn't include -1 because at -1 it's 0. But I can include -2, which is weird because there's no equal to here, but I get to use it equal to. Because this is the endpoint. That's the only reason. Alright, and they're going to be neither. You can't make that function symmetric. Okay, the last example that we'll do together is the last example on our notes. Okay, so let's do the bottom one. Where is the, I like to call it translation point?
Right to.
Right to. Yeah.
So 2, 4. Let's plot it. 2, 4.
6, 8. Ooh, we appreciate Miss Willoughby.
Awesome.
Woo! Put that on YouTube.
Okay. Let's do the moves from this point. This is a square root function. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Okay? But we have the -2 here. So the negative part is going to cause the reflection. So we go over 1, down 2. Over 4, down 4. And that's the last one that's going to fit on this graph. So I'm just going to plot what'll fit and then draw in the square root. So what is the interval that represents the domain, all possible x values for this function?
2 infinity.
2 to infinity. Now, the range, least to greatest. Least to greatest. Negative infinity to 4. Come on, baby. There we go. And that is max. Okay, is this function increasing or decreasing? Decreasing. So it decreases from that x value to infinity. No increasing. We have that one x-intercept right there at 0, 6. looking at the graph, do we have a y-intercept?
No, and
No.
it can't even go over there.
And if we went back to plugging in 0, we'd get negative 2 times the square root of negative 2. Isn't that imaginary? What does that tell us? There's not one. Okay. Does x approach negative infinity?
No.
Nope, so we got it not applicable.
You just put another like dash.
Sure. And as it approaches positive infinity, what does the function approach? Negative infinity.
This is where I need
The function is positive from 2 to 6. And then it's negative from 6 to infinity. And it is neither even nor odd. Alright, so your homework is the front only of that second worksheet you picked up. The front only of the second worksheet you picked up today.
Does not have graphs on it?
It doesn't because there is no equal to right here.
Right.
Those are just the positive, where the function is positive or negative. Huh?
How come the 2 didn't?
Because that is your endpoint.
Okay, so the endpoint will